Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, students, subscribers, and viewers. There is another problem in Vitamath, and this is a problem in calculus about evaluating limits. So the given expression is challenging. That's why I apply L'Hopital's rule in evaluating the limits of this function. So evaluate limit of quantity sine quantity a plus 2x minus 2 sine of quantity a plus x and plus sine of a divided by x squared. So notice that when x approaches 0, this is sine of a, this is negative 2 sine of a, then plus sine of a, which is 0, over x squared, which is 0 squared. So we have 0 over 0, which is in indeterminate forms. So that's why we need to apply L'Hopital's rule. And if you can remember, we differentiate independently the numerator as well as the denominator, not following the derivative rule for fraction. Just independent differentiation of the numerator and the denominator until such time that it is now free of the indeterminate form, which is 0 over 0 or something over 0. So doing the first derivative, the derivative of sine of u, imagine this is u. So sine of something is equal to cosine of something times the derivative of that something with respect to x. So that is derivative of sine is cosine, then we copy a plus 2x, and since the derivative of a plus 2x with respect to x is 2, derivative of a, that's constant 0, and derivative of 2x is 2. So that's the derivative of this first term in the numerator. In the denominator, copy this constant negative 2. The derivative of sine of quantity a plus x is again cosine of quantity a plus x, then times derivative of a plus x, which is 1, and plus the derivative of sine a, which is constant, is 0. Likewise, the derivative of the denominator with respect to x is 2x. So that's it. Now, if we divide everything by 2, because 2 is common in the numerator and in the denominator, this reduces to limit as x approaches 0 of cosine of quantity a plus 2x minus cosine of a plus x all over x. Now, as x approaches 0, this is a, and this is also a because x approaches 0. So we have cosine of a minus cosine of a, which is 0, over x, which is approaching 0. So approaching 0 over 0, that is still an indeterminate form. So that means we have to apply L'Hopital's rule again. So this is the second time we apply L'Hopital's rule. Then we differentiate the numerator and the denominator independently. So the derivative of cosine is negative sine of quantity a plus 2x, then the derivative of negative sine of quantity a plus 2x, then the derivative of a plus 2x again with respect to x is 2, then minus, then the derivative of cosine is negative sine of copy a plus x. The derivative of a plus x with respect to x is 1, then all over the derivative of x is 1. Now, checking on simplifying, so we have negative 2 sine of a plus 2x, then plus sine of a plus x. Then it is now free of the denominator. Because it is now free of the denominator, we can now evaluate the limit of this simplified expressions as x approaches 0. So we have, as x approaches 0, we have negative 2 sine of quantity a plus 2x as x approaches 0 plus sine of a plus x. So as x approaches 0, this is negative sine of a, and we have positive sine of a. So limit as x approaches 0 is negative 2 sine of a plus sine of a. Since these are like terms, the final net answer is negative sine of a. Therefore, limit of quantity sine a plus 2x minus 2 sine of quantity a plus x plus sine a over x, where as x approaches 0 is negative sine of a. So that's it for this video. I hope that you were able to follow the explanations and the solution.